Hey, Andre, and other people that might be watching this. Uh, for those who don't know, Andre is my professor, um, and I just wanted to show you some things I've been working with, messing around with in DirectX to recreate some simple shapes. So, starting off, this first shape that um, I try to recreate was, let's see if I got it here. Of course, I don't have it up. There it is. So yeah, this right here is the first shape that I'm trying to recreate. Uh, just messing around with the vertices and indices in DirectX. And that's another one. And yeah, starting off, uh, these are the 8 vertices of that shape, the 4 points of that star, and the 4 points of the star, and the 4 inner sort of armpits of the star, whatever you want to call them. And you can see here we create the vect array called vertices, and these each are a vect with a x, y, and z component. Um, the first 4 are the armpits. The last 4 are the points of the star, uh, indexed 0 through 7. So, and also these stars here are just to remind me what edits I've made, so I can remember to explain about those. So yeah, so here, seeing the next edit here, you can see that it is dealing with the byte width of the vertices array, and of course, the amount of space we need to allocate is the size of one vertice or vect times by 8 vertices. Not too difficult to understand that. Moving down, we have here another edit I've made. These are just the extra points I added to the project that Andre originally gave us. The extra triangles. My bad. So each I should explain that a little further. So each set of 3 points, or each set of 3 numbers here, reference these vertices up here. So this right here, this indice represents this vertice here. The number 1 indice represents this vertice here, and the number 2 vertice, right, represents, number 2 indice represents this number 2 vertice here. So yeah, so these first 2 triangles were given to us, and they just created a square. And I added these extra 4 triangles to create the 4 extra points to actually create the star. And moving down this edit here, this is just creating the byte width of the indices array, and of course it has to be the size of an indice times by the number of indices per triangle times by the number of triangles, right? That should be 18 of these things, right? 1, 2, 3 by 1, 2, 3, 4, 5, 6. Okay. And I think the last edit I made in order to create that shape was this here. We also need to put in a parameter into the draw index function, explaining how many indices we want to we're provided it, and that happens to be 3 times 6 or 18. Okay, so if we run that, let's build it real quick. Okay, we run that. You can see we get that box with the extra 4 triangles outside. Okay, cool. So that's the first shape I was trying to replicate. So the second shape was this here. It sort of looks like a shell, but what it actually is well, whatever. It's 10 triangles and 12 vertices. You can see each triangle has a shared vertice. All of the triangles share a vertice on the right side over there. So yeah, moving back to the code. Let's forget which one it is. Not that one. This one. Okay. So yeah, going into this sort of shell shape, I created a static const int variable called numverts, and I have set it to 12, just sort of as default. But we can change that to any number we want. Well, maybe not negatives, and maybe not too large of a number, but just now. So maybe below 3 or 4, it might mess up as well. Just maybe from 5 until a couple thousand. Let's see. Oh yeah, so basically this just controls the number of vertices. So instead of having a shell shape with 12 vertices, you could have 5 or 1,000 vertices. So moving on here to the actual CPP file, the first edit I've made is up here, where I changed it from a fill solid, this used to be solid, to fill wireframe, so that it's not a solid shape. You can actually see sort of those. It basically doesn't fill the triangles. It just keeps them as a wireframe. Moving down, the next edit I made was when initializing vertices. The vector array called vertices, I just initialized it to the size as the number of vertices you need. No big deal. And then here's where I was actually setting the vertices. The x and y coordinates. The z coordinate stays at 0 the whole time, so that wasn't too difficult, right? Here's the z coordinate staying at 0. But in order to get that circle or shell sort of shape, I had to do some simple trig. Created a delta theta, which was 2 times by pi divided by the number of vertices. So it gives you, basically divides a circle into however many vertices you have. And there I created the each, I went through this how many times? 12 times, or the number of times, and I found out what the x position and the y position should be at each one of those to create those points around that circle or that shell. And then the 0.5 here was just to make it smaller, so it wasn't the size of the entire window. Yep. And then let's see. Oh yeah, here I just had to make sure I changed the byte width, or the byte width, such that it was able to hold that number of vertices. And then moving down, so the indices are always, the number of indices are 2 less than the number of vertices. But of course, the number of triangles is 2 less than the number of vertices, but the number of indices is going to be equal 3 times the number of triangles you have. So that's the size of the index array I created, and to do that, let's see, I basically, every triangle first indice starts at 0, and then it goes to 1, 2, and then 2, 3, and 3, 4, and then 4, 5, all the way up to 10 and 11. And that will create all your triangles there for you. And of course, I had to change the size of the indice array as well. Allocate enough space in the buffer on the GPU to contain all those indices. And then last but not least, I also had to make sure that I drew I had to make sure I provided the correct parameter to the drawIndex function to draw all the indices there. Okay, so yeah, that's basically it. Oh yeah, I forgot. I need to build that. So let me build that real quick and show you the result. And also, I'll show you the result with five vertices, and also with maybe like 100 vertices. So here's the 12 vertices shell shape. And I'll go back to the .h file and change that to, how about just 5. Build that. And let's run this. So you can see here, it's 5-sided figure. Got the 5 vertices and 3 triangles there. Awesome. And let's try 100. See what happens. 100. Build that. And run it. You can see we get a more of a circle here, oval, because of the screen dimensions are not, square. You actually kind of get sort of pattern. It almost looks like a fractal pattern or a Mandelbrot set pattern. It's kind of interesting. Anyway, yep, that's all of that. All right, see you next time.